Okay, so you're doing number 2, okay, because we did number 3 yesterday. So we're going to get first the diagram drawn. I'll give you a few minutes to get the vector diagram drawn. Then I'll draw it so you can confirm you have it right, and then you can work on finding the x's and y's, adding the x's and y's, finding the result. Okay, that's it. So we'll give you a few minutes on that. So we've got a soccer player who runs 15 meters at 15 degrees north of east, and then runs 13 meters at 5 degrees west of north. Okay, so everything is north. So I'm going to start kind of down below here when I draw this diagram. So 15 meters at 15 degrees north of east. So I'm going to first have a reference line that is east. Right, and I'm going to go 15 meters at 15 degrees north of that. So it's a pretty shallow triangle. So that would be my 15 degrees. This would be my 15 meters. This would be y. This would be x for that one. And then my second one is 13 meters at 5 degrees west of north. So I'm going to draw my reference line north. Okay, and scale's important here. 13 meters is just a little bit less than 15. 5 degrees is an exceptionally narrow triangle. Right, so 5 degrees there. This is 13 meters. This would be y. This would be x. And that means that my resultant, which in this case represents the total displacement, would run from my initial position to my final position. So my diagram should look something like that. Okay. You may have drawn the blue triangle. If you drew the y and the x inside here, that's fine. It just gets really crowded, okay, because everything is over top of everything else. But there's nothing wrong with having done your triangle this way, except that everything overlaps and it gets really, really, really busy. Okay, but there's nothing wrong with having drawn it that way. All right, give you a few more minutes, then I got to calculate your x's and y's. So if I find one side of this black triangle, so I find black x, then I know two sides. Can I just use Pythagorean theorem to get the other side? The answer is no. And that's because you're using numbers that are kind of rounded off. Even if you're keeping all the decimals, they're rounded off in the calculator. It's not as accurate as using a trig function, which actually is like kind of an infinite number. Okay? So we always want to use the trig functions to find y and x as opposed to doing a Pythagorean theorem calculation to get a missing side. Okay, for your component triangles anyway. The other thing I want to address is the use of sine law and cosine law. Don't. Okay? I know that in math, there is someone who teaches you sine law. The curriculum says don't do that. Okay? The curriculum says simple trigonometric ratios. That's SOHCAHTOA. Okay? Here's why we have a beef with sine law. Of all the people we have seen try to use sine law, less than 5% consistently do it right, which is just not good enough. Okay? I know you get taught how to use it, and maybe in math it works okay, but it doesn't work here. I just have never seen anyone who can successfully and consistently use sine law to arrive at the correct answer for these. Because I know that if you know about sine law and you were pretty good at it in math, you're looking at this and going, this is way less work for there, I can get it done in no time. Except that people just don't do it right. Okay? Which is why me and Mr. Dickey, that would be the entire physics department, okay, do not endorse, condone, encourage sine law. Okay? It just isn't done consistently correct by high school students in our experience, which is longer than you've been alive. Okay? So, we're telling you, yes, I know it's tedious to do all the trig stuff, but this way works, and this is the way the curriculum says to do it. Okay? It is the way that consistently arrives at the correct answer. All right? I'm not throwing down the gauntlet for you to continue to try to use sine law by saying that. Okay? Just know that we just don't see it work. Okay? We know it can work, we know that, okay? But we just don't see people do it often enough well. And here's the other problem with it. If you do use it, and you do it wrong, I can give you almost no marks for method. Right? I mean, if you look at how many steps there are in a question like this, like I give you a mark for basically every single step. A question like this could be a 10-mark question. If you use sine law, I can give you a mark for the diagram. And after that, there's no work that I can give you anything for, because it's kind of a one-step deal. Right? And so there's just nothing there. If you do it wrong, you have a picture and a wrong answer, and I can't give you anything for that. Okay? Any other question?
So you use sine law is what I'm hearing from you.
Yeah.
All right.
Yeah.
Sounds good.
If you want to do like the reverse psychology.
Yeah.
All right, let's have a look at the rest of this here. So the next step is we got to find our x's and find our y's. All right, so if I'm finding black x is adjacent to my 15-degree angle. So I'm going to have the cos of 15 degrees times 15 meters, okay, for that side there. Okay, so 14.489 meters, and that is east. All right, then I'm going to find black y, which is the opposite side, so I'm going to use the sine of 15 for that, times 15 meters. Not confusing at all that they use the same number for the hypotenuse and the angle. So that's 3.882 meters. That one's north. Okay. Then I've got to find red x and red y. Okay. Red x is the opposite side from the 5-degree angle. So that's going to mean sine of 5 degrees times 13 meters. So that's 1.133 meters. And that's west. And then y is the adjacent side, so that'll be the cos of 5 degrees times 13 meters. So that's 12.951 meters north. Okay, so is everyone all right with the trigonometry that I did to get the x's and y's? I know I did it kind of fast, but I figured you guys have probably done that already.
So, when you solve for like x,
Yeah.
couldn't you use like for y you could use x and like plug in x to an equation to solve?
How?
Like you
Okay, you're right, I could. Here's why I don't. Then I'm using a number I calculated, and if I screwed up, which is rare, okay? If I screwed up, I'm using a number that's wrong, so I'm gonna get more numbers that are wrong. So I always go with the number I'm given, just because there's no uncertainty in that. But yes, you're absolutely right. If I calculated x, I could use x to calculate y if I wanted to. All right, so now I've got my x's and my y's calculated, so now I need to remember that my next step is to use these x's and y's to get my resultants, x and y, right? In this problem, we go 14.489 meters east, and then we backtrack 1.133 meters west. So that means that blue x is going to be 14.489 meters east plus 1.133 meters west. In other words, I'm going to do what with those two numbers? Subtract them because they're opposites. Okay, one is east and one is west. Sydney, did I lose it? Okay. All right, so I'm going to take my 14, which is up here somewhere. There we go. Okay, so I'm using all of the decimal places. So that minus that one. All right, so there's my overall blue x component, 13.356 meters east. All right, then I've got to do the same thing with the y's. Luckily, both y's are which way? North. So I just have to add them. Okay? They're essentially collinear, which is exactly how they're drawn over here on the right-hand side. Okay? This one goes north, and this one goes north. So y will be 3.882 meters north plus 12.951 meters. Okay, and again, I want to use all my decimals, so I'm going back into here. That one plus that one, right? All right, so in total, we go 16.833 meters north. Okay, so now my resultants triangle has two sides. Can I calculate the magnitude of D? Okay, can I calculate the magnitude of D here now that I have this side and this side? Again, I just use Pythagorean theorem. All right, so that's my next step. So the magnitude of D will be 13.356 squared plus 16.833 squared. Okay. So, whoop. Oh, I forgot to put the plus in there. That would be why I got such a gigantic number. Oh, it won't let me do it either. Try that again. Plus, there we go. That number. Okay, so my overall displacement's magnitude is 21.488 meters. Okay, now I also need the direction. I can use any trig function I want. I calculated all three sides. If there's a mistake, I'm already screwed. Okay, so I can use whatever trig function I want to get the angle now. I'm still going to use tan because it's my favorite. Okay, so theta equals tan to the minus 1. for me, the way that triangle works, my opposite side is 13, my adjacent side is 16. So the 13 over 16, obviously I'm putting in all the decimals when I put this in my calculator. All right, so I'm getting an angle of 38.43 degrees. And for me, that direction is east of north. Okay, so now I've got to go back and see how many significant digits I have. 2, 1. I would never give you a problem that would end up with 1 significant digit as the answer. Here's why. Here's how this answer looks to the proper number of significant digits. It just looks silly, okay, with 1 significant digit. So we're going to pretend that there were 2, because I hate writing anything to 1 significant digit. Sorry, not 4. Sorry, we'd have 20, so it would have been 2. Sorry, times 10 to the 2. So our displacement's going to be 21 meters at 38 degrees east of north, or 21 meters at 52 degrees north of east. Either one of those would be acceptable as the correct answer. Okay, yes, there's a lot of steps, but it's always the same steps. Every single one of these that we have done, okay, it worked out exactly the same. It was draw the picture, find the x's and y's, use the x's and y's to get our resultant triangle, use Pythagoras, use trig to get your direction. Done. Okay, it's always the same steps. So once you get used to them, you get faster at it. Any other questions on that one? Okay. I want you to try that one. This one has 1 extra step at the end. You're actually going to calculate the displacement, but it wants you to calculate the average velocity if the whole trip takes 540 seconds. So basically there's just a v equals d over t calculation at the end using the d you get. Okay? You can. It's a tricky draw because it backtracks on itself almost completely, okay? But just enough that it's not collinear, because if it would backtrack completely, it would be collinear. It would be super easy, okay? But I'm not that nice, so I've got to make it difficult, okay? Now, here's what we're looking at. Our first vector is 30 degrees north of west. So I want to draw a vector that is due west. And then I'm going to go 30 degrees north of that for 950 meters. Okay, so that's about 30 degrees. Okay, and this is 950 meters. Okay, this will be x, this will be y. Now, this angle here, right, is 60 degrees here. Now, the next part here says travels 385 meters, which is much shorter than this line. Okay, but it goes 45 degrees south of east. All right, so if I draw my reference line east, and I'm only going to draw it this far because it's quite a bit shorter than the 950 meters. 45 degrees is past this line. Would you agree? Okay, because this angle here is 60. That means that angle there is 30. So I need to go down to about here to get 45 and make sure my diagram is to scale, at least roughly. Okay? It's very easy for people to draw it in here, and then their diagram doesn't actually match the answer. Yeah, I drew way too far there. All right, so now, here's x, here's y. This angle is 45 degrees, and this is 385 meters. Right? So where does my resultant go? Same place it always goes. From start to finish. How difficult is that diagram to look at? Very. Everything overlaps everything else. Okay? That can be confusing. Could I, in a case like this, or if I just really get like wigged out looking at something like that, could I draw these triangles like totally separate? You can. Marcus, question.
I was gonna put that. I was gonna say that you can with a triangle. So can I draw?
Sorry.
So so what I did was I did a triangle right here. And then for this one I did a triangle right here.
Mm-hmm.
And then with those two triangles
Yes.
go.
Yeah, you absolutely could. So you flipped it, and that's fine, just as long as you remember which way everything's pointing. The
Yeah.
danger of doing that triangle is forgetting that it's going this way. But yes, you could do that if that works better for you. What I was actually getting at was that you could separate all of these triangles from each other. Okay? So I could have actually drawn this like this. Here's my first one. I can draw those triangles, and I don't have to put them tail to head. Okay? We call this the separate triangle method. Because Mr. Dickey made it up. So the name fits. Okay? The disadvantage of using the separate triangle method is that you won't see the resultant until you've calculated it. The reason he and I don't like that is we like to have the ends for it. Okay? We like to know, all right, this is what I'm aiming for. Okay? But for some people, seeing this diagram is just, it's just, your brain doesn't work that way, right? And it's just too much, it's too busy, I'm getting confused by looking at all the lines. And that's fine, okay? Because there's a significant portion of people who prefer to find the x's and y's with the triangles drawn apart from each other, and then just putting the x's and y's together at the end. Since the x's and y's, no matter how you draw them, are going to come out to the same numbers, it doesn't matter whether you draw them separately or together. You're going to get the same numbers at the end. You just don't get to see the resultant until the end if you do it with the separate triangle method. Okay? But it's entirely up to you. All right, so from here, regardless of which method I'm using, my next step is to calculate all the x's and all the y's. Right? How many people are to that step already? Okay, I'll give you a few more minutes to get the x's and y's calculated. Okay, and then I'm going to actually solve this one with this separate triangle method, so you kind of see it. Okay, so just kind of walking through this. Regardless of which method I'm using, the separate triangles, which is on the top, or all together tail to head, which is on the bottom, my next step is identical. Okay? All I'm doing is calculating all the x components and y components. Right? So black x, regardless of which method I'm using, is still the adjacent side in its triangle to the 30-degree angle. Right? Which means I'm going to calculate it by going cos of 30 times the hypotenuse, which was 950 meters. Okay? So x, black x will be 822.7 meters, and that is west. All right, regardless of which one of these triangles I'm using, okay, y is still the opposite side to that 30-degree angle. Okay, so that's going to be the sine of 30 times 950, which should be 475. Yeah. Meters north. Okay, everybody all right with that? Same thing for the red triangle. It doesn't matter whether I'm looking at the crowded tail to head version or the separate version. Red x is adjacent to the 45-degree angle. So the cos of 45 times 385. Okay, is 272.2 meters. 272.2 meters, and that is east. Okay, and as Sydney pointed out, okay, since this is a 45-degree angle and it splits it directly in half, the adjacent side and the opposite side are equal. So I can save myself a bunch of work and not bother calculating what the sine of 45 is, because the sine of 45 and the cos of 45 are the same number. Okay, so I can just write that y will be 272.2 meters north, or sorry, south. South, this will go south. All right, now I've got my sides calculated. All my x's and all my y's are calculated. What do I do next? Not yet. Before I can do Pythagoras, I have to actually build that last triangle, this green one, that I can see on the tail to head method, but that I can't see right now if I'm using the separate triangles. Okay, so this is what I consider to be the downfall of the separate triangle method, okay, is that I can't see that triangle. I have to build it and then hope I built it right. Whereas with the tail to head version, I can see it. When I build it, I'll know if I did it right because they'll match. Okay, there's no way for me to kind of check that with the separate triangles. Still mathematically the same method. All right, so if I'm going to calculate, okay, green x and green y, okay, my green x, my resultance x, is going to be 822.7 meters west plus 272.2 meters east. In other words, I have to subtract them. So 822.7 minus 272.2 will give me my overall x. So if I'm using the separate triangle method, I'm just doing this calculation. I don't see anything yet. I'm going to build it from here. Okay, so I've got west minus east, and obviously this is going to end up being west. Okay, so that's the one I want there. Okay, that one minus that one. All right, so overall, we go 550 meters west. Okay, obviously there's some decimals in there. So with the separate triangle method, that's one side of my resultant triangle, which I will draw in a minute once I have the y. Okay, so for the y, I've got 475 meters north, okay, plus 272 meters south, which means I'm subtracting them again. So 475 minus that number gives me 202.8 meters north. All right, so if I was using the tail to head method, I'm just putting those numbers in there. I already know they fit. Y is smaller than x, right? X is longer than y, 550 and 202. So, you know, I can kind of match it up and go, all right, I think I did that right. Okay, from the separate triangle method, my next step is now I've got to actually draw this triangle. So I'm going to go 550 meters west, and then 202.8 meters north, and there is my resultance triangle. It looks the same as the one I got on my tail to head diagram. I just had to build it instead of seeing where it was going to be. Okay, everyone follow me on that? And now from here, everything else is the same. Okay, now I calculate d using Pythagorean theorem. So at 550 squared plus 202 squared Okay, so my overall 586.6. meters, and then I got to calculate theta. Okay, that's the same regardless of which method I'm using. For me, that'll be 10 to the minus 1 of my opposite side over my adjacent side. So I'm getting a 20-degree angle. That fits with my diagram. It was a pretty shallow triangle, so 20.2 degrees. And for me, that's north of west. Okay, so now my final answer, got to go back and check my sig digs here, 2 significant digits. All right, so my final answer will be 5.9 times 10 to the 2 meters at 20 degrees north of west, or I could also have 70 degrees west of north if I drew the triangle the other way. And then I've got to do average velocity. Yes, this was just getting displacement. Yeah. No, you're right. Yeah, I still do have that step. So now, the last thing asked, if the whole trip takes 540 seconds, what's the average velocity of the combine? So it's just this added v equals d over t question, so that'll be 5.9. Actually, we would use the 586 because it's not the last step. Okay, divided by 540, okay, and that would give us our overall velocity. The velocity would have the same vectors as the displacement. Okay? All right, that's as involved as they get. Okay? They really don't get any harder than that. Okay? Overlapping like that is the worst and most difficult kind. Okay, we're going to have more time to practice that stuff, so don't panic yet. Next week, you can panic. Right now, don't panic.
I like to do stuff.